All right, hello. This time we are going to make our player face the cursor and shoot towards the cursor, and then we're going to look into some timers that were useful for various things in our game, like rate of fire and despawning bullets and stuff. The cursor thing is one of those things that is a lot less simple than it seems like it should be. And to some extent, I'm going to have to ask you to just write what I write and not worry too much about it. As I said at the start of this tutorial, in general, I want you to understand what we're doing and why. And I will talk through what this code is going to do and why we're writing it, but it will be a bit mathsy and a bit complicated. And good news, you don't need to know it. Look, this is a bit of code I wrote 6 years ago. I have never touched it since until today. I've used it in almost every project, and you just write it once and you forget about it forever. But like I say, I will talk through it a bit, and I want to explain why this isn't quite as simple as it seems. So what we want to do is, like, we're playing the game, we have our cursor, we want the player to look at it and shoot in that direction, shoot towards where my mouse cursor is. If we were in a purely 2D game, like if it was the view was like this and there was no third dimension, the whole Unity didn't even know about a third dimension, everything was just X and Y, then finding the mouse position is pretty easy because there's only one place it can be. It's, if my cursor is here, I'm definitely in the same spot as that enemy. But we're in a 3D world, and even though our game might just be on a flat plane, only really deal with 2D stuff, it's still, when we're looking at it from any kind of angle, it's ambiguous where our cursor is in 3D space. Our cursor is actually in several different places in 3D space. If we don't do this, but I'm just to illustrate it, if I had a second ground layer, or we're making like a multi-level game, and I put my cursor is here, where is my cursor? What's the flat position of my cursor? Well, according to the higher ground, it's in the way in the bottom left corner, right? And on the lower one, it's actually like almost on the other side of it. It's beyond the center. So this single position on our screen corresponds to several different positions in 3D space. In fact, it corresponds to all the positions in 3D space that we would hit if we fired a laser from our eyes. This is actually a thing we're going to do. Not quite a laser, not quite from our eyes, but that where our cursor is in 3D space, the answer to that question is a line that goes into the game world from our eyes. It's like a beam that shoots out of us. All of those positions along that line could be where the cursor is. It makes sense to say that in all cases. But obviously we need a clear, definitive answer to this. We want the player to look at the cursor. And so the answer to the question in our case is, well, if you travel down that line, when you get to the player's height, where are we then? That's what we really mean. When I put this cursor here, I can intuitively say, well, where is the cursor? It's between those two red enemies, isn't it? Like, we can tell. That's what we're doing automatically, and we just need to tell the code to do that. So, but like I say, it's a bit of code that. Sorry, I'm trying to get a reference doc up here, and something is yelling at me. I haven't touched it in ages. If I look away from the screen, the reason I'm getting a reference doc up is I don't remember this code. I just have to look at it and write it out. So you are not at all behind me if you don't understand any of this. So the first thing we do is we want that laser that we're shooting from our eyes, and that is a ray. So we're creating a new variable. Oh, sorry. This is in player behavior, and I'm writing it just after this WSD to move section and before the face the new position. Because once we've done this, we're going to face that position. We're no longer going to face the direction we're moving in. And yeah, the first thing we want is this laser firing from our eyes. That is a variable type called ray, and a ray is just a name for a line in 3D space. Just think of it as a laser beam. And we're going to call it ray from camera to cursor. And to create it, we are going to tell the camera to do it. So we can reference the camera by writing camera.main dot screen point to ray. So that is a function that is going to take a point on the screen where our cursor is and turn it into a ray that's firing out of our eyes. It's weird. Don't worry if you don't understand why we're doing this. And what we pass into that is input.mousePosition. Input.mousePosition, we're calling the input hotline. We're just saying, where is the cursor on the screen? That's the easy question to answer. If we're making a 2D game, that would be all we needed. Just where is it on the screen? Unity does have a fixed answer for that, and it's very simple. But if we want to know where it is in 3D space, we're going to have to ask about where we want to look along the laser beam we're shooting from our eyes. And yeah, you're probably just going to have to copy this code out, because I think like trying to understand every single term and why it's where it is pretty complicated at this stage. So the next thing we want to know, after we've got the ray, now we want to know, or we want to tell the game which, at what height do we care about? What, basically, in our vision of this, we're sort of intuitively saying that, well, the place we care about is the ground level, right? It's where the player is. It's kind of the player's height. If the player's going to look at this cursor, if I want this white thing to turn around and look at this cursor, I don't want it to look up or down. I want it to look on its level, wherever the cursor is on its level. So that flat ground level is called a plane. You might know that term already. In fact, yeah, like it's kind of similar to the geographical concept, like planes. Although that's spelled differently, so ignore that. We're creating a new variable. The type is a plane, and what are we going to call it? I'm going to call it the player plane, and we're going to create it from scratch. So sorry, I'm trying to write the word new just once. New plane, and in brackets, to create a plane, all Unity needs to know is where are we starting from and what way is up. And so, actually it's the other way around, it's what way is up and where we're starting from. So the first thing we want to tell it is which way is up. We're just going to use vector3.up for that. And remember, that's calling the vector hotline and asking it for, just give me a vector that represents up. And then for where we're starting from, it's going to be our position, transform.position. Because remember, it's the player. I have done something wrong here, haven't I? Have I? No. Bear with me a sec while I figure out why this isn't, why this is now. Oh, maybe I could just mouse over it and it'll tell me. Plane is an ambiguous reference between system.numericsPlane and Unity engine.plane. Well, I want the one that is useful to us. What is going on? I wrote the same code earlier tonight and it was fine with it. Is it because of that? Wait. Something strange has happened here. Truly can't see any difference between this and the code that worked just now. Why is all of this has gone horribly wrong as well? Everything has completely, like it can't understand what vector 3 is now? I guess let's look at potential fixes. What if, actually just to see if I delete that, we're still in trouble. It doesn't understand the code, that our existing code. That's a little bit alarming. What's going on? Don't know what to tell you, mate. Let's close and not save our changes. Now it's fine. And if I write the exact same code, it's fine. What? I think it was when I typed new. I think I broke the universe. I really don't know what was going on there. Sorry, that's a strange thing. I haven't really encountered that before. I'm going to assume it was a temporary glitch and we'll just ignore it. Okay, so that's the plane we care about is it starts where we are, our transform position, and if we tell it which way is up, then Unity can figure out how to make the plane from there. Again, don't worry if you're not entirely following this. And now, playerPlane, we're going to ask it to raycast the ray from camera to cursor, and we want it to tell us, to spit something out, a float variable that tells us how far it had to go along that ray before it hit the plane. So how long is this laser, how long did this laser have to travel before it hit the ground? And that's just going to be distance, we can name this whatever we like. I'm going to call it distance from camera. And then the very last thing we do to actually get the cursor position is something to do with the ray. It's with the ray from camera to mouse, camera to cursor, get point. So now we're talking to the laser and we're saying how far, or give me a vector for the position I would get if I traveled down this laser this far. And how far are we talking about? Well, it's that distance value we just got, distance from camera. So this is a bit weird, I've got to say. These two lines feel like we're doing the same thing twice, don't they? Like one of them is saying, how far do you go down the ray before you hit the plane? And the other one is saying, actually do go that far down and get us that coordinate, I guess. It seems a little bit complicated to me. And like I say, you don't need to understand this one. This is a bit you can just write once and forget about it forever. At the end of it all, we have a vector that is the cursor position. And this line of code below it, this lookout position, do you remember we were at this, we changed our movement code actually to enable this, where we wanted to know what position we're about to move to, and look at that. Well, we don't want to look at that anymore. We want to look at the cursor position. So lookup position equals cursor position. So yeah, all this chunk, I rushed through it and I didn't really explain this out thing is a bit weird. We're defining a variable in the middle of a function, which is a bit weird. We don't normally do that. We're creating a plane and an array, which are two things we haven't dealt with before. We're referencing the camera in this special way that I haven't used before. It's quite a lot of stuff, so yeah, don't worry about it if you don't entirely get it. And when we play, we should find that the player turns towards the cursor, and better than that, they shoot towards the cursor. Because that bit was done for us for free, because we already shoot bullets in whatever direction we're facing. So as long as we're facing towards the cursor, we'll shoot towards the cursor. So that's actually done. So that's a nice thing. It's possible that later we might want several other things in our world might want to know where the cursor is, and we might want, interface things, buttons and stuff that might want to know this. If and when that happens, we'll pull this out and put it somewhere else, and it won't be on the player. Because right now, for example, if the player was destroyed, this code for knowing where the cursor is would be gone as well, which would be a bit weird. But I'm leaving that stuff till when we actually need it, when it makes sense to do it. In the meantime, there's a few things. I noticed there's some of the shortcomings of our game revolve around timing. So we are firing bullets every update. And like I say, update is inconsistent between different computers. And also we want to be able to control this. We want to be able to control how rapidly we fire. Another thing is that if we play our game and keep firing bullets for long enough, we will eventually start to get some slowdown, because they're just going to clutter up the place, stacking up. They can cause some slightly weird physics behavior. Our player is immune to that now because we restrained their position, didn't we? But yeah, eventually this slows down. So the simplest case, both these things can be solved with timers, and the simplest one to do is the bullet one, so we'll do that first. And we are just going to create a new public variable, public float seconds until destroyed. And we're not going to set it here because it's a public variable, so we want to set it in the inspector. And our bullets are prefabs, remember? They don't live in the scene yet. They're just this single ideal. I double clicked it there and it's opened it in prefab mode. And now the seconds until destroy thing that we just defined, it's there, but it's 0. We don't want that. I'll go for like 4 seconds. That's pretty short. We could go for longer, but I want to actually see it happen for one thing. I don't want to be sitting around waiting for it to see it. So I'm just going to hold down fire now, and we should see. Is anything disappearing? Did I fail to do this? What the hell am I talking about? I completely forgot to write the actual code. I'm so sorry. Seconds until destroyed. We defined that variable and then did nothing with it. I'm a bit out of it tonight. What we want to do is tick that down. So every update, right now Bullet doesn't do anything in the update, but now it's going to take that seconds value and reduce it. Do you remember when we wanted increase by, it was plus equals? Well, if we want to reduce something, it's minus equals. Reduce it by time dot delta time, which is how much time passed since the last update. So when we're working in seconds and we're using time dot delta time, that all works out. It's all in the right units. So that will tick down to 0, but currently nothing happens at 0. To do this, we're just going to check if seconds until destroyed is less than 0. If you haven't seen this before, that pointy bracket is less than. The other pointy bracket is greater than, and should be easy to remember because the left side that's less than is the smaller side of the shape, and the side that's greater is the wide side. And so if 0 is the greater thing, then we are 0 or less. And sorry, we're strictly less than 0. And if that happens, then we destroy our game object. Destroy brackets game object. We've done that before. In fact, we do it right down there. Yeah, so we defined a timer. We set it in the inspector. I briefly forgot we hadn't written any code. The reason for that is because I do a trial run of these things, so I have written that code tonight. I just forgot that it was in the trial run, not now. And then every update, basically all the time, we are ticking that down, and once it hits 0, if seconds until destroy is less than 0, then actually do destroy us. Now we should see some actual effect. Sorry, I want to check something. Why isn't that saved? Yeah. Should see some bullets get destroyed. There we go. And of course, they ping out of existence in reverse order. There's something, while we're on this, they do disappear rather abruptly. And if we wanted that to look a bit nicer, normally I wouldn't really be polishing at this point, but we can actually do that fairly easily, which is by changing their scale. So this is this seconds until destroyed. It starts at 4 and it's ticking down until it's 0. Shortly before they destroy, we would like them to shrink. I think that's a nice way of having them transition from existing to not existing. It's very commonly used in games. And we know how to access our scale, right? It's transform.local scale. Excuse me, not local Euler angles. Local scale. We can set that to something. And if we set it to seconds until destroyed, sorry, it has to be a vector. So we start with a vector 1, which is just 1 in all directions. No, we're not going to do this. Sorry. No, we are going to do this. So this is a thing I did in practice, and it turns out to be the wrong way to do it. But it will be funny, so we're going to do it. So yeah, if we set our scale to however many seconds we have left. So when we have 1 second left, we're 1 big, and when we have half a second left, we're only half the size, and then when we're 0 seconds left, it will be 0. So we should smoothly shrink down to nothing. Obviously, we don't want to do that right from the start, because seconds until destroyed starts at 4. That's bigger than 1, so that's not normal scale. So we will do, if seconds until destroyed is less than 1, we do this. Excuse me, I didn't do an opening bracket. I'm going to have to... Wow, I made my whole computer go crazy. Yeah, okay. All I was trying to do is get the formatting to look consistent. And if you copy and paste something, if you cut and paste something rather, it will format it for you when you paste it, which is kind of nice. Yeah, so if it's less than 1, let's use it as our scale, and if it's less than 0, let's destroy ourselves. This is wrong, but I'm going to show it to you because it's I found it kind of funny. So we shoot some bullets. And then they explode. It's actually pretty cool. They're basically exploding bullets at this point. And when there's lots of them like that, they really pop off. This is actually kind of cool. I'm sort of warming to this. I'm kind of thinking maybe we want something like this. We're going to put it in our back pocket as something we might do later. But if we do want them just to vanish, though, our intent was to make these just shrink out of existence. There is a better way of doing it. We can just, instead of setting us, okay, sorry, the reason that's happening, I forgot to explain, is our bullet scale is not 1, 1, 1, right? If we open up our bullet prefab, our scale is actually 0.1, 0.1, 0.6. So when we set the scale to 1, 1, 1 at time equals 1, we actually made it bigger, and we made it square, or cuboid. We made it a cube. And that's why it kind of popped and went big and spewed everywhere in this quite fun way. We don't want to do that, though, in this particular case. So the easier way I found of doing this is just that if we multiply, anytime once our seconds left to live is less than 1, if we multiply our scale by that, that will make us smaller. It will, if our seconds left to live is 0.8, then we will shrink our scale to 80% of what it was. And this will kind of stack up because we will shrink ourselves, then we'll shrink ourselves again, we'll shrink ourselves again, and the amount, the fraction of our previous size will be smaller and smaller, which is actually quite a nice way to scale something. I'll fire loads of bullets. Maybe I'll just keep on firing. Yeah, look at that. It's lovely, isn't it? That's a really kind of subtle disappearing thing. We could, it would take more code to make them exactly linearly go from 1 to 0, so that, it goes 0.9, 0.8, 0.7, 0. Whatever. Our code is actually a kind of a fancier smoothing algorithm. It's where it's the smaller it gets, the faster it disappears, and that turns out to be quite nice for our purposes. So that's using a timer for bullet life, and we can also use a timer for rate of fire. So on our player behavior, I'm going to declare a new public float called seconds between shots. You'll notice I like to get the word seconds in there because that way we're being clear about what the units are, and we know it's not number of frames or number of something else. I just like to be as explicit as possible with variable names. And then I keep forgetting to do this. I'm going to remove this debug log on startup. That was just a test thing. We didn't need that. Down here in the firing code, I think I'm going to change this comment to just say firing because we're about to make it a bit broader. What do we want to do? We want to, excuse me, pasted the wrong thing, not having a good night. We've got a value for the seconds between shots. What we really want to do is something like if the time since the last shot is greater than seconds between shots or equal to it, then we can fire. So we need to track that. And the seconds between shots, I made it public so that we can adjust it in the inspector. In fact, let's just go and do that now, because watch me forget that I haven't programmed anything yet and test it. Where is our scene? Here is our scene. Seconds between shots, let's say 0.2. Seems reasonable, that's 5 shots a second. But if we want to count how long since the last shot, there's no reason for that variable to be public. But we do want it to persist. We want it to be something we can refer to. We can change it this step, and its value will be kept next step. So we do still want it up in this area where we declare things that we want to kind of be universal to our instance. I don't know if that's a sane way to say it, but So we're just going to not use the word public. It's just going to be float seconds since last shot. You can put the word private in front of it, but I'm pretty sure that if you don't, if you just leave the word out, then it's fine. So basically, we say public if we want it to be public, and if not, it's fine. And we are going to define that one here, because remember, we're not making this pop up in the inspector. The reason we don't set any of these values in code is because the inspector is going to set them, because we made them public. Since this one is not public, we actually do need to set it here, and we're going to set it to 0. How long since the last shot? Wait, that's actually wrong, isn't it? We want it to, like, how long since the last shot when you just created, it's not 0. We didn't just fire, right? We want to be able to fire. So its initial value is actually going to be seconds between shots, which we can't use. Oh God. Why can't we use it? Because it's not a static field. Are we going about this wrong? Seconds since we last fired. We could just start this with 0, and it wouldn't be a noticeable problem, but it's a bit weird because it means basically your gun is locked when the game starts, and there's no reason for that to be the case. If we gave it like a really long time between shots, then this would be more of a problem. I guess we just define it, and we don't set it to anything here, and then in start we say seconds since last shot equals seconds between shots. So this area, setting values to each other in this area is a dangerous game, it seems. And you're really supposed to do it in start, so we'll do it there. Fine. And then seconds since last shot, that's the thing we want to tick up all the time, right? Every update, that should be increased by time.delta time. We don't need to know if we've ever fired. We don't need to know anything about the current firing state, whether you're holding down fire right now or you're not. Regardless, we're just going to increase that. We're just going to keep adding to it. And then only if, so we're going to have, this is now going to depend on 2 things. Right now, creating a bullet depends on, are you holding the fire button? And now we want it to also depend on if seconds since last shot is greater than seconds between shots, and input.getButton fire. And is done by 2 ampersands, one after the other. That's just a thing. That's just how you do it. So, and greater than I already explained. We're actually going to modify this slightly because strictly this doesn't really matter, but it ought to be greater than or equal to, and that's just greater than with an equals after it. And that means, so that'll be true if seconds since last shot is exactly seconds between shots. In practice, that's almost never going to happen because time steps are uneven and very precise. But just because it kind of matches the spirit of what we've called these variables, if the amount of time since the last shot is the same as however many seconds were allowed between shots, then we can fire. So that should be right now. Yeah, I guess that's a bit slower. It's not much slower. Let's increase it and check that it's actually having an effect. It's not having an effect. It's doing nothing. Okay. Why this time? We don't reset it, that's the problem. Seconds since last shot. After we shoot, we should set that to 0, shouldn't we? Yeah, that's what I forgot. So what was happening there was we started ready to fire, and then when we did fire, it was always passing this check because we start in a state that passes this check, and then we also never reduced it because I forgot to write that line of code. So yeah, when we fire, seconds since last shot is now 0, right? Because we just fired. That should be obvious to any idiot writing this code. Okay, that's definitely slower. In fact, that's probably too slow. Need more enemies to test it against. This is a good illustration of a principle I've talked about recently called show me too much, which means when you're tweaking a variable, don't stop when it feels about right. Only stop once you've gone too far in the other direction. So when I was adjusting that seconds between shots, it's like, maybe this is better, maybe this is working. Didn't feel bad, but actually it was having no effect at all. And so you need to keep going until you see like, okay, this is bad now, it's too slow. Because otherwise you might just be imagining the changes, because that does happen. Okay, that is probably enough for today on the main lesson, because I'm going to break even more things if I try and teach anything more serious. But while we're messing around, I don't even know if this is a mess around thing, but there's one more timer we could add here that would be fun, and so I'm going to add it, which is what if our enemies replicated? If they had a public, yeah, is this going to work? We'll find out. A public float of seconds until multiply. Let's say spawn. And we'll give them a private float of, sorry, we'll do it like our rate of fire, seconds between spawns, and our private float will be seconds since last spawn. And we'll have to do the same thing where, wait a second, this is going to be 0. This is going to be 0. Unlike our rate of fire, this can start at 0 because we want it to tick up and not spawn anything until it reaches a certain value. And that value will be, so in update we're going to increase it by time.delta time. And then we're going to check, is seconds since last spawn greater than or equal to seconds between spawns? And if it is, we want to instantiate if we say instantiate game object, that is copying ourselves. We're going to make a new game object so that's just the same as us. Just make a new one of those. But that's going to, I think the new one is also going to spawn another enemy immediately. So perhaps we want to, before we do that, say seconds since last spawn is 0. So the same thing that I got wrong with the rate of fire there, where I forgot to reset it to 0 after we fire. We're going to set this to 0 before we spawn the new one, because I think it's going to inherit our counter. Our timer will be copied as well. And so we want it to be back at 0. And then we're just going to create a new enemy on top of ourselves. I think this should work. Wait, no, it's going to go horribly wrong. Yep. This is an understandable error, though. I just hope I can actually... Has Unity registered my click? It's very hard to say. Oh, I could click pause, I guess. That would help. This happened multiple times in practice as well, and I was always able to get out of it, but not right now. Is there... I think there is a keyboard shortcut to pause as well. I don't know if that's going to be any more responsive than clicking the button in the interface. Damn it. I might just have to close Unity. Okay. Yeah, better close Unity. All right. It's curse night here at Tutorial Land. Why did that happen? Just because we hadn't gone into the inspector and set that seconds between spawns to anything. So it defaults to 0, so the spawns are infinitely fast. I was so careful to avoid the infinite spawning problem in other ways. But yeah, if we want to set that value, we want to set it on the prefab. And seconds between spawns, I think, something like, should we say 3? And then I want to double check, I've changed it in the prefab, but did that affect all of our instances? And if I click on them each in turn, I'm looking at the second stream spawns, and yes, they're all 3, so we're good. So let's see if this goes wrong. There it is. 3 seconds after spawning, they all replicate, and of course the ones that copy them are also replicating. And it becomes a roiling mass that I have to keep culling with my now reduced rate of fire. And I'm actually going to let it get out of control because... So at this stage, I think it's probably... Yeah, I think it's replicating so fast now that I won't be able to take it out even if I wanted to. I kind of don't want to. I want to get mobbed by the horrible glossy mass. Oh god. Oh jeez. And if I let that carry on, it's going to obviously crash Unity again. So that's not a good game mechanic to keep because it will eventually crash the user's computer. But it's kind of a cool effect. And I'm going to stop there now because otherwise I'm going to ruin everything more.